When we talk about what makes AI so powerful, our minds usually jump to two things: massive, massive data sets and these genius algorithms, right? But what if I told you there's this secret ingredient, this crucial step that happens right in the middle, that's often the real hero of the story? That's what we're going to dive into today: the art and science of feature engineering. Okay, so it all kicks off with this really fundamental problem. You can have literally all the data in the world, petabytes of it, but if you just dump it into an algorithm, well, you're probably going to get garbage out. So what's the deal? Why is raw, unfiltered data so often completely useless to even the smartest AI out there? All right, think of it like this. It's a great analogy. An AI model is like a world-class chef, and the raw data, that's just a pile of unprepared ingredients sitting on the counter. We're talking dirty potatoes, fish with the scales still on, a whole mess of spices just thrown together. The chef can't work with that. Now, engineered features, that's those same ingredients, but they're perfectly washed, chopped, seasoned, and measured out. They're ready for the chef to turn them into a masterpiece. See the difference? It's moving from pure chaos to total clarity. So that whole prep process, that magic that turns messy ingredients into fuel for our AI chef, well, that's what we call feature engineering. And it is the solution to our whole raw data problem. So here's the formal definition. It's a pre-processing step. All that really means is it happens before the main learning begins. It's all about transforming that raw data into a set of inputs, or features, that are just vastly more effective for the model to learn from. You're basically making the data speak a language the AI can actually understand and use. And the impact? Oh, it's huge. This isn't just about tidying up. It's about performance. Really good feature engineering directly leads to smarter, more accurate models. I mean, it makes sense, right? The better the ingredients, the better the final dish. This is what takes an AI model from being just functional to being truly insightful. And what's really fascinating is that this idea, this concept, it's not just for AI. Physicists have been doing something kind of like this for ages. When they create dimensionless numbers like the Reynolds number to understand fluid flow, they're essentially engineering a feature, a new, more meaningful piece of information from a bunch of raw measurements. So, how do they actually do it? What are the tools that data scientists use to craft these perfect features? Well, let's take a look inside the engineer's toolkit. So the whole process kind of breaks down into four key stages. First step, you've got feature creation. This is where the magic really starts. You might take a user's height and weight, for example, and combine them to create a brand new, way more insightful feature like body mass index. Simple, right? Then comes transformation. This is all about cleaning things up, handling missing values, fixing errors. After that, we get to dimensionality reduction. Sounds complicated, but it's just about cutting through the noise to find the most important signals. You're simplifying the data without losing its soul. And finally, feature selection. This is where you strategically pick only the absolute best, most relevant features to feed your model. You want it to focus on what truly matters, not get distracted by the fluff. But, there is a twist in our story. This whole process, it isn't without its dangers. You can actually have too much of a good thing, and that leads to a problem we call feature explosion. It's one of those weird cases where more data actually creates more problems. A feature explosion happens when the number of potential features just becomes so massive that the model gets completely overwhelmed. It can't effectively process all the information, and its performance actually starts to go down. It's like giving that chef 1,000 ingredients when the recipe only calls for 10. It just creates chaos. This kind of thing often happens when you're automatically creating features by combining existing ones. I mean, think about it. If you have 10 features and you start creating combinations of 2, then 3, then 4, the number of possibilities just grows exponentially. And all of a sudden, you've got this data monster on your hands that's just impossible to tame. Now, the good news is data scientists have ways to fight this data monster. They use cool techniques like regularization, which basically penalizes the model for being too complex, or they just get really, really aggressive with their feature selection to tame that explosion. The key thing to remember is that while this is a super serious challenge, it's a manageable one. It just takes a lot of skill and strategy. Okay, so given how complex and time-consuming this can all be, the big question becomes, can we automate it, right? Can an algorithm actually do a better job than a human expert? And the need for automation is crystal clear. Doing this stuff manually is tough. It takes deep, deep knowledge of the specific subject, whether you're talking about finance or biology, and a ton of painstaking trial and error. It's a major bottleneck in building effective AI. So how effective is this automation really? I want you to just look at this number for a second. 615. What do you think that represents in this battle between human and machine? So that number, that's how many human teams of expert data scientists were beaten by one single automated algorithm in a competition. Let that sink in. Out of 906 teams, this one algorithm, it's called deep feature synthesis, outperformed 615 of them. I mean, wow. That is just a staggering testament to how powerful automation is becoming in this space. And hey, this isn't some far-off future technology we're talking about. There are powerful open-source tools that are making this automation accessible right now. Tools like Feature Tools and GetML or TS-Fresh for time series data, they're designed specifically to do this heavy lifting, which is really democratizing access to high-level AI development for everyone. All this automation is pushing us towards a totally new frontier in how we manage data. It's not just about creating features for one model anymore. It's about systemizing the entire process for the future. And that brings us to the feature store. Think of it like a central library for all those perfectly prepared ingredients we talked about. It's a dedicated place where features are stored, organized, and documented, ready to be checked out and used by any data scientist or any model in an entire organization. But a feature store does way more than just hold data. Critically, it stores the recipe, the actual code used to create the feature. It can then apply that recipe to new raw data automatically and serve those features consistently to any model, whether it's for training or for real-time predictions. It's just a massive leap in efficiency and reliability for the whole team. Which brings us to our final thought. As these automated tools get better and better at the science of creating features, what does that leave for us humans? What's the role of human creativity, of our domain expertise, of that gut intuition, in a world where a single algorithm can beat 615 expert teams? That right there is the question shaping the entire future of data science.